So let's do this. 3-5, solving systems with 3 variables. Don't take notes on this. I just want you to see where we're coming from with our answers here. So if you look at this first no solution, okay? Three variables, think 3 dimensions, right? Usually we have an X and a Y, that's 2-dimensional. Now we're plugging in a Z dimension as well. So you have 3 dimensions. You have depth, width, and height to think through with these, okay? Andrew, you need to put your iPad away.
I told you.
Not out. Well, stop doing it. And then you won't get caught doing something you're not supposed to be doing. Okay, so 3 things. You have 3 options for solutions. If those 3 things don't all meet somewhere, there is no solution. Okay? If they all meet in exactly one point, like this guy, that teeny little point right there where they meet, there's one solution. Or if they lay so nicely that all 3 meet at a whole lot of points, like this, where they all meet at a line. Does this feel like geometry all over again? Where 2 planes intersect is a line. Then you have an infinite number of solutions. Your solutions will just keep going, okay? What we're going to be doing today is this, okay? We're going to be finding that one solution that we get from 3 setups.
Is this like the bonus?
It is like the bonus question, right?
I got that right though.
Did you?
I did.
Good. This is a little more complex. What? The bonus? Hey, we're not talking because there's still a quiz going out. We'll chat about it later. Okay, so we're going to start this with elimination. Okay, and I'm going to color code as much as I can just so I can tell you like equation, the orange equation or the whatever. Sam, if these colors, can I do like neon green? Does that stand out? Like, is this going to be distinguishable? These were the 3 colors I was going to use. Can you distinguish those?
Well, like my favorite color
Yes?
is green and purple.
Okay. Well, then I'm doing it just for you, Andrew. All right, so elimination. I'm going to give you 3 equations. The first one is x minus 2y plus z equals 7. The second one is 3x minus 5y plus z equals 14. And the third one is 2x minus 2y minus z equals 3. Okay? Now we are trying to eliminate. What's the goal with elimination problems?
One variable.
You want to get to one variable, but how do we get there with elimination? What are we trying to do? Opposites, okay? Do you have opposites anywhere?
Yes.
We do. We have a lot of opposites going on with our z's, right? So what we're going to do is we're going to set it up with equation, well, this is our system, okay? I'm going to call this equation 1, equation 2, and equation 3, okay? We're going to take equation 1 and equation 3 and simplify those, okay? We're going to do a little bit of elimination with those 2. So 1 and 3, okay? So equation 1 is x minus 2y plus z. You don't necessarily need to do all this writing. I'm just trying to be uber clear with you where everything is. Equation 3 is 2x minus 2y minus z equals 3. Okay? So if we're going to eliminate, we can add these together right now, and we will get 3x. Let's just do this in black so I'm not confusing you with different equations. 3x minus 4y equals 10. Okay? So that's 1 and 3 together. we need another one without z to be able to work with our x's and our y's together. So we're going to try to ditch z again using 2 and 3, because 2 and 3 can cancel out our z also. Do you see that? So 2 is 3x minus 5y plus z equals, actually, you know what? They're together right here. I'm not going to rewrite them. Is that okay with you?
Yeah.
They're already right on top of each other, so I'm just going to use those. So this one, 2 and 3 together, right? We're doing this. You would do 3x plus 2x is 5x. Negative 5y minus 2y, or plus a negative 2y, is a negative 7y. Our z's cancel, and we get 17. Okay, so now we have these two equations. We'll call this equation 4 and equation 5. Okay, from there, you know how to do elimination or substitution. We're doing elimination on this one. So we're going to take those two equations and try to eliminate either the x or the y. How can I eliminate my x or my y? Is it helpful to see them on top of each other? Right. If we get 5 and 3 to 15 and negative 15, life will be all beautifully in order. So I'm going to multiply this top equation by 5, and I'm going to multiply the bottom equation by what then? Negative 3. Okay, so the top equation is going to be 15x minus 20y equals 50. The bottom equation is going to be negative 15x plus 21y equals negative 51. Okay, and now we can eliminate using those two. So if I add those two equations together, my x's are gone. Negative 20 plus 21 is 1y. 50 plus a negative 51 is negative 1. So y is negative 1. Okay, now from here, it's a whole lot of just plugging back in. You can plug that y value in right here, right here, right here, or right here, right? Because then it will isolate and leave us with just an x. So I'm just going to do it in that top one. I'm going to plug it into 3x minus 4y equals 10. So it's going to be 3x minus 4 times negative 1 equals 10. And simplify that. So it's 3x plus 4 equals 10. So take away our 4. And 3x equals 6. Divide by 3. So x is 2. Okay, so now we have an x and we have a y. We need a z. I would go back up to one of your original ones. I would probably do this one. Well, it doesn't really matter. Actually, maybe I'd do this one because then we don't have a negative z at the end. Let's do this top one. You can do any of them. That's the beauty of this. There's lots of places you can go. Are you still with me right now? Is this making sense?
You can plug it.
Hey, you wake up.
It's just the same thing we've been doing, just with the extra thing.
Mm-hmm.
You can plug it into any of the equations.
Because it gets more complex. I'll show you in a minute where there's word problems, where there's real life things where you got to do this. You can plug it into any of the x's and any of the y's to solve it. Okay, so if we use this equation, 2 times the x value, 2, minus 2 times the y value, negative 1. Oh, shoot, I was going to do the top one. Oh, well. Minus z equals 3. Okay, so this is 4 plus 2 minus z equals 3. So 6 minus z equals 3. Take away the 6. You get a negative z equals negative 3. And then just divide by negative 1 to make it positive. Z is 3. Okay? Here's your answer. You have all the x, y, and z. your answer is the coordinate 2, -1, 3. X, Y, Z.
So, to the left, down one, and
Back
forward
3, forward 3, depending on how you're looking at it. Yes.
What would positive mean?
Yes. Toward,
Toward myself.
I mean, I guess it depends how you have your axis sitting, right? Because you're,
There we go.
yes. Okay? Don't worry about you're never going to have to graph it. Don't worry about the graphing of it.
Oh, really?
Wait, we're not gonna. She sent us.
No, how are you going to graph 3-dimensionally?
Yeah, send us home with you. All right.
I should send you home with 3 dimensionals. Okay, second one. Are we good? Does that make sense? Okay, here's your second one. X plus y plus 2z equals 3. Hey, she still has a quiz. 2x plus y. Oh, sorry, that's a plus. I'll take it. Thank you. 2x plus y plus 3z equals 7. And -x minus 2y plus z equals 10. I all but guarantee I'm going to make a mistake on one of these today because there's just a whole lot of numbers everywhere, right? But I'll do my best. Okay, what can we cancel right now? What is eliminatable? The x, if we use the first and the third, okay? So we're going to do equation 1, x plus y plus 2x. Again, or 2z. You don't need to rewrite this. I just am rewriting it so you can see it. Equation 3, -x minus 2y plus z equals 10. Okay, so we're going to add those together. X plus -x goes away. Your x is gone. Y plus a -2y is a -1y. Plus 2z plus z is 3z. 3 plus 10 is 13. So we have this equation eliminating our x. Okay? Then we want to eliminate an x somewhere else because we're not trying to just get rid of like, oh, well, now let's do the y on the other one. No, we need the same thing eliminated. Hey, put your phone away. You with me? Yeah, you should be. So we're going to try to get rid of another x, okay? I don't really care which, you could do 1 and 2 or you could do 2 and 3 because you already did 1 and 3. Do you have a preference? I did 1 and 2. Let's just do 1 and 2. So if we take equation 1 and equation 2, you're going to multiply the top equation by what? If we're doing 1 and 2?
2.
-2, right? So if we're going to multiply by -2, it's -2x minus 2y minus 4z. You have a question, Eller? Equals -6.
You could have done 2 and 3
You could have done 2 and 3, yeah. Okay. And now you have 2x plus y plus 3z equals 7. Okay, so add these together. This cancels, your x's cancel. -2 plus 1y is a -1y. -4z plus 3z is a -1z. And -6 plus 7 is 1. I did that backwards on my other one. Okay? Still with me? What do I do now?
You got a elimination.
Now take these two, right? Put those two together with no x, and we can do elimination there. So I'm going to do -1y plus 3z equals 13. Right now, they're not going to cancel. So I'm going to do the opposite of all of these. Just multiply by a -1. Don't go now. Don't go now. No, that's why. Pay attention to the next one. That's faulty reasoning right there. Okay, so if I take the opposite of each of these, this is going to be a positive 1y, a positive 1z, and a negative 1. Okay? Eliminate. What do we get? 4z equals 12. So I took, yeah, which means there's several more steps. I took these two, right? I took this one and this one. They are not opposites of each other right now. So I took this and multiplied the whole thing by negative 1. And now they are opposites here.
Why was this created?
You need opposites. Because it's beautiful. I'm going to show you a problem where it applies in just a minute. Bear with me, people. Okay, so divide by 4, z is 3.
Are you gonna give us the real world connection?
Yes, in like a few minutes.
Okay, I'll wait.
No, because I'm in the middle of a problem right now. Okay, so if we plug this in, you can plug this in here, 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 or here, right? Which one? 1z plus 1y plus 1z equals negative 1? Yes. Okay, so we'll plug z in here. So it's 1y plus 1 times 3 equals negative 1. So that's y plus 3 equals negative 1. Take away the 3. So y is negative 4. Okay? Now you need x. So again, you can go up, let's go here. This one's simple. Okay, x plus your y, which is negative 4, plus 2 times your z, which is 3, equals 3. So I'm just plugging it into this equation. Okay, simplify that. Negative 4 plus 6 is a positive 2. So take away that 2, and x is 1. So your answer is 1, negative 4, 3, right? X, y, z. Okay? Okay. This next one's easier.
Wait, you didn't tell us the.
Yeah.
Because that's example 4. Just let me finish the process. This one's quick. Okay, this one is substitution. So here's your setup. You have 2x plus y plus z equals 8. You have y plus 3z equals 6. And you have 2z equals 4. Okay? We don't want to do elimination here. We want to do substitution because we have a beautiful place to substitute. If we know 2z is 4, what is z?
2.
2, right?
It mixes up with my 5s and my 2.
Put the bar through it.
I do.
Well, then why does it get mixed up?
Because there's so many numbers.
There are a lot of numbers. Okay, so z is 2. Guys, this one's easy. Look, z is 2. We got that done already. Plug that 2 back in here. Y plus 3 times 2 equals 6. Y plus 6 equals 6. Y is 0. Okay, got our y already. Now plug y and z here and here. 2x plus 0 plus 2 equals 8. 2x plus 2 equals 8. So 2x equals 6, divide by 2, so x is 3. So your answer is 3, 0, 2. See, substitution's quick, right?
So fast.
It's satisfying. I know, it's beautiful.
Ms. Rubin, can we
Yeah.
put x into any equation that there is?
Can you what?
Can we put z into any equation that there is? Or does it not work?
Well, you want to put z into this one because this one has
No,
an.
no, 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 no. Like a previous equation.
No. Z is not z always. Z is just a placeholder for some number that actually belongs there.
So like,
You mean, could we just plug in z instead of x as like we want to work with z's instead of we want to work with x's?
so it could be like y equals 3x plus 5 plus z.
No. That changes the whole equation.
You get the same answer.
If z is 0, but what if you multiply by z? Then it's not.
Yeah.
No, stop
You're
talking.
making your own equation.
No, you don't get to just make stuff up.
Isn't that what people do? They just like, you know what?
No, absolutely not. The things in math do work.
Hey, but they
They
have to
do.
be up at some point.
They're not made up. They discovered that they work.
Some point.
Okay,
Z is
here we go. This is a word problem. This is the real world where this comes into play. Okay? Go for it. Guess. What? Not nowhere. Right here. I'm going to show you. You guys are such Debbie Downers today. Goodness.
My name is Sam. I'm not Debbie.
We've lost hope.
Okay, here it is. You are running a clothing store, okay? You have a budget.
$58, $69.
Does Bo go to Does he? I'm not genuinely asking. I feel like I haven't seen him in years.
We have a budget
of $6,000 to restock 200 shirts.
You say $200 shirt?
200 shirts.
Is that what that is?
No, it's not tips. That's renting for calculators. Okay, so here it is. You can buy t-shirts
Take tips.
for $12 each.
I think Amazon has cheaper shirts.
But are they as good a quality?
Yeah.
No way. You can buy polos for $24 each. And you can buy rugby shirts.
Rugby?
Yeah.
It's actually
They're
a shirt that
striped.
has color, but it's not colored.
Okay, for $36 each.
It looks like it has a color, but it's fold over.
Okay, stop talking about the shirts now. Move on. Okay, this is the lesson. This is the end of it. We're ending it right now, if you just pay attention. Here's the point. It says, if you want to have twice, excuse me, I'm talking. You should not be.
Are you recording this?
Yeah.
This is just
If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy?
Can you say by the time I would have enough money to start a clothing store, I would have forgotten starting this?
But then it's going to come back so quick because you already learned it. Because you're going to be like, oh, Mrs. Verhoeven taught me this. I remember. Okay, so here's the deal. You have all this information to work with. You need to set up a system. A system is 2 or more equations, and we're going to solve those. So it says we're trying to buy 200 shirts. So we're going to call this, t-shirts are going to be our X, polos are going to be our Y, rugby shirts are going to be our Z. Okay? I suppose you could, but we're gonna do X, Y, and Z. Okay, so what is X plus Y plus Z gonna equal? 200. You have 200 shirts, so X plus Y plus Z has to be 200, okay? We also know that we want twice as many rugby shirts as polo shirts. So our rugby has to equal 2 times the number of polos, right? So Z equals 2Y. And then we do the money side of it. What would the money side of it look like?
12x plus 24y plus 36z equals 6,000.
Precisely. Okay? 6,000 was the budget you had at the beginning. Okay? Okay, so here's the deal. If we're going to solve this, the first thing we're going to do is we're going to simplify that third equation because as it turns out, all 3 of those are numbers that are divisible by 12. So we're going to start there, okay? We're going to turn that equation into X plus 2Y plus 3Z equals 500. Okay, so we just took this and we divided by 12 on all of them. Isn't that such a nicer set of numbers to work with? Okay? Okay, so you have these 3 equations now. 1, 2, 3. What shall we do?
The bottom one by negative plus the top one, and then you find X, Y, and then you put Z in.
So we know what Z equals, right? Z is 2Y.
Yeah.
So let's substitute it in both of our equations. Substitute it here, substitute it here. So it's going to be, for this one, it's going to be X plus Y plus what?
2y.
2y, right? Z is 2y equals 200. Okay? Now we're going to substitute this one, the 2y, in place of z. So it's going to be X plus 2y plus 3 times what?
2y.
2y equals 500. Okay? Let's simplify that again. This, you have a y plus a 2y. So we can say X plus 3y equals 200. And then this one, 2y plus 6y is 8y. So X plus 8y equals 500.
Multiply the top one by negative and then eliminate.
Right, so if we multiply the top one by a -1, it's going to be a negative X, a negative 3y, and a negative 200. And now we can do elimination. So we're going to do elimination, add these together. We get 5y equals 300. And we're going to divide by 5. So y is 60. What does that mean?
I need a 60 polos.
60 of that type of shirt.
And I need a
Okay?
20 rugby shirts. And then
Okay, hold on.
I need 20.
Hold on. So z equals 2y. That was up here, right? So we can take that y and plug it in. So z equals 2 times 60, which means z is 120. Okay, and now you can do, I would take this one, X plus Y plus Z equals 200. So X plus 60 plus 120 equals 200. So X plus 180 equals 200. Take away the 180, so X is 20. That means your answer, this one you don't need to write as a point, because a point doesn't make sense here with what we're talking about. So X was t-shirts, right? So it means 20 t-shirts. Y was polos, so 60 polos. And Z was rugby, so 120 rugby shirts.
Do people really buy striped shirts?
Okay.
that often?